Alright, hey, what's up guys? Ready to get started tonight on our build. I haven't checked Facebook in a little while. I'm not sure what flight controller ESC won our poll. But it looked like our hobby wing stack was pretty well in the lead when I had looked earlier. So it looks like tonight we'll be building up our King of Hearts with the hobby wing 4-in-1 and flight controller stack. All right, this is the first time that this is going together. We got that going tonight. Aside some of these other pieces here. The other one we were looking at the Speedix, and we were looking at the what is this? HGLRC. Looking at those ones. I think everybody in our Facebook poll decided that they wanted to go hobby wing. I also think the hobby wing is a pretty neat flight controller. So that's the way we're going with that tonight. What else we got? We gotta fit our top plate on. We gotta see if the snap fit of our 3D printed part is good. I didn't do any kind of compensation shrinkage or otherwise, so we'll see how that goes together. Our kind of our little battery strap roof that holds the receiver inside. That's gonna go into our top plate right there, and that's gonna form the top of our King of Hearts stack. And I didn't finish popping out the little pieces of carbon here. So I cut this earlier this week. There we go. And I haven't really filed it down or anything, so it's a little sharp. But we can get around to that. We can get around to that a little bit later. Speedix ESC, we can set that aside. So there's our hobby wing set up there. I gotta go find the jumper wire to put these together. Our camera mount. So that's ready to go. We were talking about machining the Delta 5 timers last week, and so I've got a video queued up for that. I haven't cut the actual enclosure yet. All I've been doing so far is making test cuts on the router to see if the machine is capable of handling this this bar of 6061. And boy, it makes some interesting noises, and she's got a bit of chatter, but it is cutting it. And it's cutting it pretty well. I'd say, like, horsepower wise, it's able to handle it. I can see, I've measured the part, and the part is not the right size, so there is a lot of there's a lot of flex in that machine. So if I'm going to try to hit certain numbers, I know I'm going to have to go around this part several times, make some spring passes, and maybe even compensate by changing the size of the part to get it where it needs to go. So anyways, on this test piece, this guy was supposed to be 4.9 inches wide across the length here, and it's actually I believe like 4.92, right? So it's about 20 thousandths oversized. So that tells me that cutter is leaving 10 thousandths of material behind. Yeah, I'm getting like 4.914, right? So maybe 7 thousandths of material is still left on there. That's all the flex in that machine is basically it's deflecting away instead of cutting all the way to the correct depth. So you have two choices there. You can come around for what's called a spring pass, where you try to run that edge again, and because you're taking away less material, there's less force and then hopefully less deflection, and you can get closer to your final number. Or I could like go into fusion and compensate 7/1000ths, offset this, knowing that there's going to be that much deflection in the final part. But it's also probably a taper, so it's probably closer to 4.9 at the top, and it's probably further away at the bottom as that cutter gets deeper. Anyway, so I've got some video of machining my test piece here. So I did a couple passes on this face to try different depths and step overs for the face. And then I did this pocket with like a shoulder. I did that two different ways. So the top pocket I did with a real shallow depth of cut, but a really wide step over. And then when I did the lower pocket, I did a really deep cut, but with a really shallow step over, right? Two different ways, trying to get the material removal rate about the same and see which way the machine, likes better. Does it like going deep and taking a shallow pass off the wall, or does it like staying real shallow and it's okay taking a really big step over? And it doesn't seem to matter one way or the other. So really it's going to come down to how fast am I removing material. And then I also did a really deep helix bore in the corner there. So I had a 3/8 end mill in the machine, and we tried to bore out a 5/8 hole here with a helix, and it did it, but it did not like it. So there's some things we got to adjust in the final program before we go try to attempt to make a good one. But it was pretty promising that I didn't tear the machine apart, and I didn't break a cutter, and I didn't kill myself. So that's good. Let me see if I can bring up our video and I can walk through how it was running this on a router that was designed to cut wood and plastic and not cut aluminum. And you'll see that it's noisy and it's chattery, and it's because that machine was never built rigid enough to cut metal. It's got the horsepower to take a good amount of material out, but there's too much flex in the frame of this machine. Yeah, the reason for that is that you've got to cover, generally on your router, you're trying to cover a sheet of wood or plastic. You're trying to go 4 feet by 4 feet, 4 feet by 10 feet, however big. They're big machines. And so those gantries, it takes a ton of material to get those gantries rigid, right? So when you're looking at these like desktop routers and stuff like that, especially the ones that are all aluminum, they're not going to be super rigid, right? When you look at a mill, there's a lot of steel there, and the trade-off is that the work envelope is a lot smaller. You have a little desktop mill or something like that, it'd be a lot more rigid, a lot more steel, but you end up with maybe like 12 inches by 8 inches that you can work on versus 4 feet by 8 feet. Okay, let's see video here.
Cram Nitram 1.
What's up, Marty? Back at you. Alright, so where are we at? We're out in the barn. Oh, okay. First thing I had to do was get my CNC prepped up to hold a vise so that I could hold on to that piece of aluminum without the workpiece vibrating on me. right? So I had a old Chinese, 6-inch vise that was loaned to me, and I have an MDF spoil board for a table, right? So my table's wood, not even wood, right? It's just compressed cardboard or sawdust, whatever. So it's MDF, and I can't just attach that big chunk of aluminum directly to the wood, to the spoil board, because the forces of that cutter would move that thing around on that wood, right? So I needed to get down through the spoil board and actually attach to the subframe of the machine, which is steel. I figured getting down and attaching to the steel of the frame, it was my best shot at getting solid, rigid work holding. And then if I get that piece held on tight enough, then all it's going to come down to is how rigid the gantry and the spindle, the router head, all that, how stiff that stuff is. And so I grabbed these scrap pieces of aluminum here, and I'm back at my other shop, and I've just got this in the mill. It's not a CNC, it's all manual. So I'm just boring 2 holes in these like 1.5 by 1.5 aluminum bars, and those are going to go underneath my spoil board and attach to the subframe of the machine. So these 2 holes, they line up with the 2 holes that are in the vise. And you'll see I'll put the vise on top of the spoil board, and then I'm going to go underneath my CNC with these bars, and we're going to bolt through the whole entire stack. The cutter I'm using on here, rather than using a regular twist drill bit, I like these things. I had to look up the name of it. It's called an annular cutter. These ones happen to be from Rotabroach, which apparently is like a UK company. But they have a hollow center, and so it's more like a carbide hole saw, and they drill large holes in aluminum really quickly. So I'm a big fan of those. And so anyway, so I got my bars made up, and here we are back at the other shop. So on the router, and you can see here's the spoil board. I got this 3/4 inch sheet of MDF sitting on top of like a welded box frame, right? So there's like 4 steel tubes that run the length of the table, and so I'm drilling these 4 holes to straddle one of those cross members. You'll see kind of when I go underneath the bolt up what I'm hoping to accomplish here. By straddling that steel member, I can sandwich the whole thing together and get a good setup. I've pulled up some of the MDF material, so I'm just taking a razor blade and I'm scraping all that material off and trying to get it as level as possible. Now my spoil board hasn't been faced, so it's not the most level thing, which I find out later just how far off it is across the 12 inches of this part here. So anyways, alright, dropping some bolts in, and then under the table. Okay. So there's cross members going both ways. There's like a 2x6 or so rectangular tube going left to right, and then I'm getting on top of this shorter cross member, which is like a 2x2 steel tube that goes between them. And getting onto that cross member and then drawing it down is what's going to give me some rigidity. Here I don't have an indicator because I'm not a real machinist, so I am taking the cutter and I'm just checking the clearance of the cutter to the to that fixed draw on the vise, and I've got the bolts kind of snugged up, and I'm tapping it around, trying to get it as parallel as possible to the X travel of my machine. I got it pretty close. At least by eyeball, it looks like it was right on. Of course, it wasn't. But Fusion spits out these really nice setup sheets, which is cool. So I've got my setup sheet sitting there, which is telling me exactly where I have to locate the material and how deep my my operations are going to go. So I grabbed a bunch of scrap material so that I could get the material up 3/4 of an inch, because I only want to grab onto the bottom 1/4 inch of that bar, because I'm going to come around the outside and, you know, get the outside to its final dimension. And so I want the least amount of vise in the way as possible. And that 1/4 inch is plenty to hold on to it, even in this little Chinese vise. There I am, touching off on the top of the material with the little paper method. Just kind of slide a little piece of paper underneath the cutter until the cutter grabs the paper, and you can kind of zero your machine out there. And then I'm sneaking up on the side of the material, and I'm just spinning the cutter. And then when I feel one of the flutes engaged, when I don't exactly zero it out, you have to add half the size of the cutter. But I'm basically locating the upper left-hand corner of that work material, and my zero height is the top of that material. So this is my first attempt earlier this week, and I just figured I'd hit it with some WD-40, because WD-40 is great for everything. From what I understand, at some point I had heard that it is a good cutting fluid for aluminum. I think it's like kerosene based or something. But anyways, there she goes. There's our first cut. And it was getting a little toasty. You can see it's just smoking that WD-40 right away. Now I'm in there with some air trying to cool that thing down. And I got nervous. It was starting to curl that material, so I stopped it and decided to take a shallower cut. So here I raised the cutter up, taking a shallower cut. And right now I'm just running the machine back and forth by hand on the controller. You can see me just sneaking over and running back and forth. So yeah. So I just took a little material off the top by hand just to get a feel for what feed and speed the machine was comfortable doing. That first cut was a little too much right off the bat. So anyways, here we are. I've faced off the top by hand, and now I'm coming back in. This is the CNC program running again, and we're going to finish up this facing operation with some new values that I put into Fusion. And because the WD-40 was not doing the trick, I hooked up the mister, and so that I'm just holding my hand. I didn't bother to rig anything up to point that thing at the cutter, so I'm just kind of holding it by hand, and I can use it to blow the chips out of the pockets and stuff when we get there. And that's like a
William Hawk kerosene was used in the old days.
Yeah, I thought I had heard kerosene was used for aluminum. The mister, I've got like oh man, I forget what I didn't make a note of what the coolant was, or the cutting fluid. But anyways, it's a mix of water and a cool mist or something like that. Anyways, it's mostly water with a little bit of the cool mist thrown in there, and it was doing a really good job. Everything stayed cool. I could feel some of the heat on the chips when they were hitting me, but for the most part, the tool and the workpiece were nice and cool. So anyways, it's a little slow. I can't take much material off in a single pass, but hey, getting the job done. So here's that first pocket where I'm only taking a shallow cut, but I'm taking a kind of a bigger step over. And it's working. That's working fine. One of the things that's fighting me is that this cutter is pretty much shot. You know, I had to look at it under the microscope, and it was pretty dinged up in the corners. And my buddy was telling me that that big corner radius that's on this thing is going to add more cutting force. And not knowing any better, I kind of felt like having the corner radius would reduce some of your cutting force, but no, he said that having that corner radius is going to increase your cutting force. So now that I know the machine can handle cutting the aluminum, I feel comfortable, you know, spending $100 on a cutter. So I'll probably get something with a much smaller corner radius, or no corner radius at all, just a square end though. But the 3 flute design seems to be working all right. I've got a lot of cutter hanging out there. The reason I have so much hanging out is, 1, I've got to do that really deep helix, but 2, this cutter's got a reduced shank on it, and basically I have it all the way in, right up to that where the shank is like necked in. I picked that one because I thought that it might help me by not like rubbing on all the walls as we're going around. But I don't know if that made it better or worse, because it's a lot of tool hanging out. So we're already talking a lot of chatter, and so that's not helping. Oh, right there I forgot to turn the air compressor on, so I was out of air. I stepped away, turned the air compressor back on. There we go, blew the pocket out and restarted it. So here's that operation where I'm like,
William Hawk, what size shank do you need?
It's 3/8. I'm using 3/8 on here. Here I'm taking my depth of cut is 3/8, same as the diameter. But I've got a real shallow step over. And I don't know if you can see the chips coming out, but the chips look good, and the machine was doing this operation just fine too. So I think either way is valid. You can hear, I'm quiet. So you can hear the 2 corners where the chatter is bad. And what I'm finding is that there's a spot in the spindle mounting plate that has flex, and it only has flex in one direction. And I think when the cutter forces are working against that flex, that's where I get that really bad chatter. And so I think if I'm gonna keep doing this on this machine, then I might have to design a better mounting plate for the spindle. And I'll pull it up. I've got the video in here showing exactly where I think all this chatter is coming from. And you can see it's a bad design. I don't even think that it has enough strength to cut wood that well because of this weak spot. Okay, right here. So you can see, maybe I'll pause it for a second. Let this thing focus. Okay, yeah, right there. So I've got only 1 point of attachment for my router head, which that's not great to start with, right? So my motor rocks on this point right here, and you can feel it. So while I was cutting that aluminum, I was, touching different parts of the machine to kind of see what was vibrating and what felt good. Now the workpiece actually wasn't really vibrating. The workpiece felt good, and the gantry didn't feel bad either. But the router head, you could feel at the top of the router head, you could feel the vibration at the top of that motor. And so that thing is rocking back and forth because it's lacking that like second bracket up at the top. It's convenient because I can loosen it up and I can drop the motor down when I'm doing really deep cavity molds and stuff like that. But for this kind of work, it needs another bracket up high. And then the worst part, the killer, is this right here. This is a 1/2 inch aluminum plate. So it's not steel. It's just aluminum, and it's a 1/2 inch thick, and there's nothing. There's no gussets. Just that plate, and it is rocking and rolling on that right there. I think that's where the majority of my chatter issues are coming from, because the machine's actually not too bad. I mean, it's all steel, except for right here, this piece of aluminum here. It's a steel gantry, steel table. It's got pretty beefy linear bearings and stuff. The ball screws are a really good size. It's ball screws on all axes. It's not rack and pinion, it's all ball screw. But that right there, it's cantilevered way out from the linear bearing, right? Linear bearing's way up at the top, and my cutter is way down here, plus the extra like 2 inches of stick out. I think that's the source of a lot of my problem there. Right, so there's my 2 bearings up there. Yeah. That could use a redesign, I think. Either you swap that plate out for a steel plate, or I got to come up with something that's gusseted and then holds the motor in 2 places. And I might be cutting fairly successfully after I get something stiffer up there. So here we are, kind of finishing up that pocket. There's like 2 step downs to get down to the bottom of that pocket. Where do we go next? I think this is going to do the outside. Oh, here's the plunge. Wait for it. I just about stalled that thing. Just about stalled that cutter.
It's doing better than I thought it would. Defiantly need a shorter tool.
Yeah, I should have used a shorter tool. I should have stopped what I was doing. This is right there. That's the deepest part there. You know, I want to go all the way to the bottom of the material, so I got 1.5 inches to go, right? And I thought, well, if I have a 1/2 inch cut length on here, and then the rest of it is reduced shank, that maybe that'll help save me some horsepower when I'm down in there. That was my thought when I was choosing the tool. Anyways, it did not like the bottom of that helical bore. It just about stalled the machine out. I had to act quickly and grab the RPMs and crank them all the way up to try to push some more horsepower back into the machine so to finish it up. It didn't crash the machine. It finished the bore and came back out amazingly. So it didn't stall completely, but man, those RPMs were way down there. And boy, when it came out, here you can see the tool when it goes in, and you can see the tool when it comes back out. It is coated in aluminum. Well, it's a coated tool, so it pretty much came back off, but yeah. Covered in aluminum now. And I didn't stop to check. I let it finish the next operation, but one of the flutes is jammed. It's filled with aluminum. The other 2 flutes were fine, but one of the flutes got packed with some nice melty chips. So anyway, here we're going around the outside with a cutter full of aluminum. But, I don't know. It's removing the material. It's not failing. It's, holding up. So, just as it sits, I could probably machine out one of these timer enclosures, although it's not going to look great. And I think if I did do something about that, the way this machine holds the router, I might even be able to get a halfway decent finish on it. I think that's where almost all the flex is in this machine. Like I said, while I was cutting, I took there was a couple times where I kind of just went around and touched the machine in different spots to just feel what was going on, feel where the vibrations were coming through, and most of it's all right up in that router head right there. So this is like my roughing operation to get rid of most of the material. I think I left like 20 thousandths for a finish. And what I did for the finish, which I didn't see it before in Fusion, but I finally found it, was just a ramp, a continuous ramp the whole way down the face of the material. And it worked out good, except for the fact that I put a number in wrong. But I have that in Mastercam, and I like doing that operation rather than stepping down and then going around, stepping down, going around. I like that continuous ramp. I was a little too aggressive with the ramp because I took the ramp all the way to...
Von Haas, how is a router different from a mill? RPM?
I wouldn't say it's just RPM. I'd say it's more of the design of the machine. I don't know if there's specifically a spec that makes something a router and something a mill. I mean, we're doing milling right here, but like the router has a gantry, right? So got that bridge across the top in order to put large material underneath it, and that gantry travels back and forth to, cover these huge sheets of material. So you're talking 4x8 sheets of plywood, 5x10 sheets of plastic, or whatever. Whereas the mill is going to be not so much a gantry, more of you've got your column and a table underneath that column, and your work pieces are going to be smaller. Although there are mills that are fairly large, a large mill might be like 2-3 feet wide by a foot or 2 foot. That would be considered a fairly small router. A desktop router does 2 foot by 3 foot, whereas 2 foot by 3 foot in a mill is a fairly big mill. And the mill is going to be extremely rigid, so this machine might weigh 1,000 pounds or 1,500 pounds, and that right away will tell you that it's not a very rigid machine because there's just not that much steel. And that's the end. And a mill, a decent sized mill, is gonna weigh thousands and thousands of pounds, right? It's about being rigid in order to cut metal. You've got to be more rigid than the material that you're cutting. So, the routers are generally composites, plastics, woods, stuff like that. And your mills are generally your different ferrous and non-ferrous metals. But that's generally, I guess I'm really being very general. I'd say there's a little bit of crossover between the two. But hey, Haas, this is a mill. This is just a manual mill. We can see that it's a column in the back, and the spindle comes out from the column, and the table slides back and forth underneath it, and there's a lot of steel there, right? This is like a desktop mill. So this is a very small mill, and it probably weighs just as much as my router does. Maybe more. I don't know. So, this lube, I don't know if anybody still uses this stuff, but this is Anchor lube, and I just wanted to say I really like Anchor lube. There's nothing like it. It's like water-based soap or something like that. Not toxic, and awesome. Anyway, that is making our test cut for the enclosure. Let's see if I can bring that guy up. So I just kind of drew up drew up this end piece just for this reason, right? Just to kind of set up these operations. I'm gonna walk through these quickly here. So you've got our facing operation here, and here we are. Our final values ended up being 11,000 RPMs and 58 inches a minute with that 3 flute cutter there, and my step over was 0.1125. So like 30%. I think that's about 30% step over. And the machine was happy. Was happy facing at that speed, and it gave me a better finish than my first pass that I did by hand. What I did by hand was a little heavier, and I think I was going like 84 inches a minute, and it was pretty rough. And this, I'm just kind of reaching over and like running my fingers on it. It looks bad, and it is bad, but I think for what we got, it ain't too bad. That makes sense. So anyways, here's that high pocket. You can see that it's a lot of really shallow step downs. If I bring that up, so a little bit more RPM, 84 inches a minute faster, and we're at that 30% like step over 1125. And I'm machining in both directions. When I come back conventional, I'm only taking 74. And my step down, there's my step down. So I'm only dropping down 50 thou every time I go down. And that didn't seem too bad. The second pocket, which it handled just fine as well, a little slower speed, 11,000 RPM, and a faster feed rate, so 120 inches a minute. And I think that has to do with like the chip thinning, right? So if you're cutting with just the very edge of that cutter, you can't go too slow, or you're just like rubbing. You can't get the tooth to actually engage the material, and that can make a mess too. So it's actually running pretty fast. So 120 inches a minute, spindle speed down a little bit at 11,000. Let's see my passes. So my optimal load there, I'm only stepping over 20 thou. So it's a real shallow step over. But I'm plunging in 375, so 1 times the diameter. And both these operations, going shallow, going deep, they both seem to work just fine. Same amount of chatter. Yeah, same amount of chatter on both of them. So it didn't seem to matter too much which one I went with. Our helix bore, I'm gonna have to work on this a little bit, because when I got to the bottom, she just about stalled out, and I think that's just kind of a combination of I don't have flutes running all the way up, so it had a hard time clearing material out of there. You know, there's no coolant coming out, like coolant through, where you have coolant coming through the center of the cutter in order to flush the chips out. Nothing like that going on, so the chips aren't getting cleared out, and so it was making a big mess when it got real deep. And so I'm gonna have to take a look at that. You know, we're 10,000 RPM, slow as the spindle goes, and it's probably using the cutting feed rate of 39. And our pitch, we're going like 40 thousandths with each revolution down. So maybe half of that and keep everything the same. We'll see. We're gonna have to work at that. Or maybe do it in 2 or 3 sections, right? So clear half the hole, come out, go back in, clear the other half, come back out, just to get the chips out of that thing. My buddy over at Nitro also said that you could pre-drill this hole, even run a 1/4 of an inch hole down the center of it, and that cutter will have a lot easier time, because now you're not like center cutting the whole time with that end mill. So even relieving that hole might be the way to go. Although when you don't have a tool cutter, things like that make you cringe. Hate changing tools on a collet. And here's our adaptive clearing for the outside. I'm not crazy about how long this took. It just seems like there should be a better way. You know, it was way too many step downs. That took forever. Here's that helix, that ramp, not a helix, but a ramp, where I gradually lower the tool down. I think 375 was a little bit too aggressive. I didn't get a good finish, so that would need to be adjusted. And I did the same thing in here. Just a ramp down in there. So anyways, that's that. So I'm going to have to transfer those feeds and speeds over to the operations that we set up in our timer. So I'm going to take what I learned from the test piece and apply that over here. So I can start making changes to these operations. You know, I look at that and say, okay, that's, you know, that's too much of a step down over there. And that's too much of a, no, this one probably be fine. I'm gonna have to make sure I'm not engaging too much material on this finish pass, and I probably need to do multiple finish passes as like a spring pass in order to get this to the correct size. Like I said, this piece is like 7 thousandths over in all directions, so I have to make a couple finish passes to get this thing down to the right size. Otherwise, like if I try to drop in like a little acrylic window in here, it's not gonna fit. So more experimenting to do. That's gonna be the next project, is to try to knock these guys out. Not a lot of time available on the mills these days. Production is going well these days. So I know Nitro, those guys over there are busy. All the machines are like non-stop over there. So not a good chance of like slipping a little project like this in there. So good for them, and that's just forcing me to learn some new things on the router. But I think a lot of it has to do with these like adaptive tool paths in Fusion, right? Or the high-speed machining that's in Mastercam. If you were trying to do these with regular pockets, the old school way, the router would really hate me. And it comes to like when you get into these corners, every time you make one of these hard 90-degree corners and it buries the end mill, the machine would probably do more than complain. It would probably quit on me. So we're using some of this new fancy software in order to make machines do things that they were never intended to do. Here's the other cheater thing here. So this is the G-Wizard. So last week I went over the free tool that was on Helical's website. What was it called? Their machining Pro or something like that. So they've got a little calculator to help you with feeds and speeds. You just have to kind of look up one of their tools. This guy here, G-Wizard, it's free for 30 days. I have a license for it because it's pretty helpful. You can put in, you can kind of define your machine. Yeah, it's got a bunch of machines to start with, but you can basically tell this that you've got a really sloppy machine and not a lot of horsepower, right? And it'll try to find good feed and speed settings for you that'll work for your machine. So like if I come to Shopbot, let's say a Shopbot with a Porter cable router, right? That's pretty close to what I have. Okay, so we'll select that and come in here, and we're doing 6061 material, and we can tell it what kind of tool we're working with. So I had like 2.5 inches of stick out, and I have 375 for a shank and 375 for a cutter. Flute length was 1/2 inch, and my corner radius was 30 thou, I believe. And my material, it was carbide, and it was coated. I don't know. I'll leave that because I don't know what it's coated with. And 3 flute. Okay. So there we go. So I told it what cutter I'm using. And now I can start throwing some values in here. So cut depth, 50 thou. Cut width, 1125. Okay. There we go. 30%, 13%. Okay. Here's my 3.5 horsepower Porter cable router. Here's my max RPM and my minimum RPM, right? Those things only go from 10 to 21. The router I have goes to 23,000. Anyways, inches per second. Actually, can we change that to inches per minute? Setup. I want to tell it inches per. I'm not used to looking at inches per second. So. Okay. Is that better? Yes, inches per minute. Okay. So when I come in here and I've defined my cut depth and my cut width, and I can tell it that I'm using high-speed machining, and we come in here and accept that high-speed machining, it's going to kick out some recommended values. So for cut depth and a cut width of that size, it recommends 14,500 RPM. Is that in the way? 14,500 RPM and 175 inches a minute. And you can also see its plunge recommendation, its helix recommendation, and its ramp recommendation. And it has this handy little slider here that says, what do you want to do? Be aggressive and remove a lot of material, or be conservative and get a better surface finish? And if you come up here to this box up here, it's got your material removal rate. So that's how efficient you're being with your machine, right? Or with your time, I guess. So you're removing 0.98 cubic inches a minute. Horsepower. How much horsepower this operation is going to take. And here's your tool deflection. So it's going to look at how much stick out you've got and what these settings are. And it's going to tell you how much deflection to expect. So you can kind of, this number is really going to kind of tell you how much chatter you're going to have given a decent machine. Now you can come in here and say that, well, my machine
William
is
Hoff,
very
one
rigid.
recommendation also is climb milling.
Yes. Yep. It's got its little tips, and it's telling you to use climb, use a coating, and use coolant mist or lube recommended for aluminum. So those are the 3 tips that it has for you. And yeah, so down here you could tell it your machine is rigid, but mine is not. And okay, so like if I take the slider over, let's say halfway between conservative and aggressive, you can see that I've lowered my tool deflection, and I've lowered my horsepower requirement and the torque on the spindle, but I've also lowered my material removal rate by about half, right? So now it's gonna take twice as long to machine at these values, right? But it's less torque on the machine and less deflection with the tool. So now it's telling me, well, back off to 13,000 RPM and 96 inches a minute. Okay. If you get into a rubbing situation, you'll see that, like, okay, as I go and get more conservative, you see the deflection is lowering, right? 19%, 17%. But at some point, we're going to cross a line there. Okay, now these values aren't so good anymore. Now my deflection shot up to 75%. And I could be wrong, but what I think that is now you're getting into an area where the cutter is starting to rub, and it's not doing an efficient job of cutting. You're not feeding it fast enough anymore. So, I don't know. It's pretty, it is a pretty cool tool. And so I can kind of put in some of the settings I was using. So the deep pocket that I was doing, I was in 375 and only taking 20,000 with each pass. Okay, and I have to adjust my high-speed machining. Yes, okay, so it's kicking back. It says, okay, yep, you still got plenty of horsepower. You're only really using like 6% of your spindle. Deflection is up there, right? Deflection is high, torque is high, but nothing is red. We're still within the spec of the machine, and my material removal rate is up at 1.1. So I'm doing pretty good. So 1.1 versus the other pocket, I was 50 thou deep with a 1125 step over. Okay. So here we're looking at a lower material removal rate unless I go, let's see, full aggressive. Okay, so now I'm close to that 1.1, but not quite, right? So that maybe that other strategy is better, or at least more efficient with your time. I'm taking material out faster. So anyway, another fun tool to play with. You can also, see what happens when you say, what happens when I go up to a half-inch cutter and I'm going much deeper, right? Let's see if I can get some of these values to turn red. Okay, right, so now I've got a value that's turned red and said that cut depth and that cut width on your machine with that much stick out and yada yada is no good. You got a huge amount of deflection and a massive amount of torque there too, right? Still within the horsepower of the spindle, barely, but that torque is very high, and this tool deflection is going to be insane. So that starts throwing up red values, and if I exceed the horsepower of the machine, let's see if I go a little deeper yet. Deeper. Okay. Well, it didn't turn red, but I can see over here that it's telling me that cut like this is going to require 6 horsepower, and I don't have it. I'm at 170% of my spindle power, and I'm also at my RPM limit. So how's chat doing? Anything chat wants to see with the G Wizard while I've got it open? I can start, I think we can start probably putting this quad together here. So that's G Wizard. That's our fusion. And there's an update to install for that. Okay. Over to our little build here. So anyways, take a look at this. I had to order screws for this silly thing because the hobby wings have a 2mm hole in them. I'm not crazy about, and I'm wondering if 2mm is even going to catch my 3D printed part there. Probably not. I kind of made the assumption that that was a 2.5 millimeter hole. That was my bad for making that assumption. Nothing you can't fix with McMaster Carr, though. Anyways, what do we where do we go with the ESC and the flight controller? Were we ESC on the bottom? Let me see. Hell out of fusion. I don't recall what the thought was there. I think ESC on the bottom, right? Flight controller up on the top. Fire up SolidWorks and make sure I got it right. I know we solved this problem earlier. What else do I got for screws and stuff here? Standoffs for these little guys. Okay, and what is our wiring harness? One. Sure. Capacitor came with that guy. Is this the right one? Yep, that fits. Okay. Let me get these guys tinned up before they're too buried. Open up the live stream quad. It looks like the flight controller is sitting up on top. So our ESC's on the bottom. Okay. We gotta be smart about which way we face that USB port on there. And which way we face the batteries. Should probably be face up. And oh, heads fit. I drilled these out for 3mm, knowing that some of these boards are 3mm, some are 2.5, some are 2. I was afraid that that screw head might actually pull through 3mm, but it's just fine. Hopefully I found something long enough. Got 25mm. Oh, maybe they're 20s. In any case, it was the longest thing I could find in 2mm. So we're gonna have to deal with it. If it's too short, we're gonna have to make adjustments. That's how it is when you're prototyping stuff and building it for the first time. Go down the road and we find out that, oh, get a 2mm by 25mm standard part size. SolidWorks said it exists. Whoop. Actually, SolidWorks might not say it exists. The hardware, the toolbox in SolidWorks is going to be based on the standards. Okay, goes in there. And the crown is the back of the quad, and up here where this bolt pattern is, that's our camera mount. Yeah, it's down like that. And I see a problem already. Okay, so when our battery strap comes through, it's gonna come through right where those wires go up. I think Fender might have pointed that out. I wasn't paying attention. So we're gonna have to creatively solder those wires so that they are not in the way of our battery strap. That's where sometimes it would be nice to model every little detail, every nut and bolt, every piece of wire. battery strap, all that stuff. Because then you can find that stuff earlier. Peel that sticker off.
Matt Fender, what did I do? I heard my name.
Ah. I said, I think I recall you warning me about the battery strap coming through certain places. Yeah, I'm just looking at where the battery strap comes through, and on this Hobby Wing ESC, because it's got the little, kind of got its little wings for the solder pads, that the wires can't come straight off of this board, because then when we put our battery strap through, we'll have a problem. So I think I have to get creative and like come down from the top. Get creative with the wire routing here. Hopefully it's a strong enough joint. So usually what I do is I go around the board before I put any wires on there. I go around the board and put a nice little pool of solder onto each pad. One of the things it does is a lot of these boards have ROHS solder on them. So ROHS, and that's reduction of hazardous substances, I
Matt
believe.
Fender, run them up over the board, then turn them out.
Yeah, that's what I'm thinking. So yeah, so a lot of the solder that ships on these boards, you'll find that it's difficult to solder. It's because there's no lead in the solder. In order to meet, certain standards, they don't use lead in the solder, so it has a really goofy melting point, and like it crystallizes weird and doesn't flow good. And so you're kind of replacing that that ROHS solder with something with lead in it. This happens to be 60/40, so there is lead in here. So don't eat it. Let your children play with it. But it's nice to work with. And so I'm just running down the pads, kind of replacing the factory solder they put on here. Or looks like they actually just kind of floated on there when they did the surface mounting. It doesn't look like they actually put a bead on there, but I'm going down each motor pad and put a nice little blob of solder on there. That'll help me put the motors on really quick, rather than trying to hold that piece of copper there and flow the solder in there. So even here, here's the I need to get a better camera for zoomed in. Overhead camera is probably no good, but I'm flowing the solder onto the main battery wires as well. So if Marty is still awake, you guys can critique my solder job here. And so there we go, nice and shiny. Not exactly edge to edge there, but
Matt Fender, I hate pre-soldered pads. I think it's my second biggest announce during builds.
yeah, you might as well get rid of that ROHS solder, right? I mean, just don't put it on there. Yeah, so there's my main wires, and there I've redone the ESC pads there. So that comes in later down the road. Easier to put those wires on there. And they're just kind of looking for a nice little shiny puddle there. It's not dirty and it was hot enough. And you're kind of looking for it to like flow out onto the pad. Not be, you don't want like a little BB sitting up on top of the pad. You want to make sure that it flowed out to cover that pad. So what do we got to solder on this flight controller? I'm going to have Spectrum, so I need the 3 volts. Ground. I might have to look up what I need here. There's 3.3. Not sure where I should go in with the maybe receive 3. That looks like a good pad. S-bus. What's S-bus pad gonna be? Maybe that's where I go in, or is S-bus pad gonna be like inverted or something like that? Probably what that is, right? And somewhere in here, voltage in, out, 5 volts, ground, LED.
Matt Fender, you have to watch it on the inversion.
Yeah. I don't want to plug into that S-bus, do I? I want to just choose one of the RX pads. Match it up in Betaflight. I'm gonna get my ground and my 3.3 started. I don't know if you saw how fast that is, but it doesn't take much. I'm at 750 degrees on my soldering iron, and I have a big fat dirty tip on my soldering iron. I bought a smaller one, which would be handy, but what? This is getting the job done. That's that, and I'll show you my embarrassing, disgusting soldering iron. Oh yeah, covered in all kinds of goodness there. So let me just wipe it off a little bit. Yeah, even after wiping it off, it looks
Matt Fender Hobbywing says use
yum.
3.
TX3, or I'm sorry, C3. Okay, that's not far from the far. There. I wonder if I could do that under the microscope successfully or not. Oop, sorry.
Matt Fender RX.
Solder over here if that's too far for me to reach. Let me see which pad I should do. Voltage in pads. Let me pull up this website and see. I can't read it very good. Heavy wing, nanostack. And let me see if I got wiring diagram. That does not look like this one. Nope, that's not the same. What am I looking at here? A 4 micro stack? Smaller nano stack. Yes. Where's the manual? Learn more button. Manual. Okay. Do they have a good diagram? Good company will have a good diagram. And they do. Okay. Oh, V in, V out. Ah, there's an OSD. Okay, forgot that. So that's what V in, V out is. Good thing I checked. V in, V out. That's video. Next to it, VB in voltage battery. Let's see if I can solder under the microscope or not. On my solder on my really expensive tablet here. Actually, it's old. Microscope. Nope. Give myself a little bit more room here. Okay. BB plus. That's it. That's how quick that is. Oh, I just try to get like a little little bit of a blob started on the tip to wet the tip, and also to help transfer the heat down into the soldering pad. And then I'm actually like feeding the solder into the pad, not into the tip of the iron. I'm feeding the solder down onto the pad after you've gotten the pad hot. Okay. That's that. Let's see what our orientation should be for this. Okay, so we gotta get that plugged in. Here. Like that.
Matt Fender, what VTX is it?
VTX, I think we're going to... I don't know what we're going to use. What's the new hotness for VTXs right now? That work? Yeah, that'll work. That'll work just fine. You don't have to get crazy and twist this or nothing. Yeah. Next standoff's on. Can I still solder? Yeah. Standoff's down. And put a stealth on here. Have a stealth.
Matt Fender, actually, if you have room, turn it 90 degrees so the motor pads are front to back, not left to right.
That's even worse. The board's even longer in that direction, Fender. And then you have the wiring harness coming out. So I think this
Matt
is
Fender,
our
what
best
the clearance is
orientation.
for the camera mount.
The camera mount should be good. We're gonna come out the back with our wiring harness, and our camera should be nice and clear up here. And in fact, where do we have to go? So our camera's gonna sit here, and then our video in is right here. So we should have a comfortable amount of space around this. I dropped one of the standoffs onto the floor. That was bad. That is really tiny. Ooh. Perfect. There's big cracks in 200-year-old houses, so I didn't think I was going to see this standoff down there. Perfect. Could throw a baby through some of the holes in the floor in here. Okay. Stack up nice. And
Ben B was Loom near TX5GS modeled in this at one point.
yes. Yep. I've got some of those. Although, like, that thing's bigger. It's bigger than the Stealth. The Stealth is nice and tiny. Or the Tramp. Okay, so that'll actually push on there with this 3D printed part. Oh, snap fit on this guy. Orientation. Our receiver goes towards the back. Yep, and we got this little chamfered edge to the front. It's TPU, so
Matt Fender, there
should
that
be able to make it go.
It is basically a VTX03 but with a MMCX.
Oh, you bad. That might be a decent one. I like watching Bardwell do the goggle modules. The U-Bad one, to me, looked the best. Ooh, she goes. Snapped in. And it fits in the hole. Okay, so no kind of compensation on the part. I just kind of threw this part in the printer and it snapped in with a good amount of force. So I think it'll pop out. See if I can get that. Might be a little bit dark, but the printed part fits into the machined hole perfectly. There's no gap there. So that came out pretty good. And you can see our little snap there. Holding the parts in. Yeah, that worked. I don't know how crash proof it is, but sure makes for easy assembly. And then this guy go down on top. Now, the fact that these are 2mm screws going through here makes me think that that stack could shear. I'd feel better with the 3mm stuff, but I've also got the battery strap sandwiching the whole thing together. It's not great that you need all the systems to work perfectly in order for it to function properly. That doesn't really give you much of a safety
I'm
factor
soldering
there.
a 4-inch right now for Havlock.
Huh? What's that? Oh, Benny Mac soldering up a 4-inch. Sweet. 250 class or just a 4-inch? Motor wires. Battery wires. Wires here.
Ben B
Okay.
250.
250? Awesome. I have to start planning out our races. So we've got 3 classes, right? 3 classes right now. Open class. Should be all the multi-GP stuff, the regional and everything. Then we've got 250 class. Our awesome sub 250 gram quad. And then we have Lone Star spec. It's not the quad that's spec, it's a Lone Star spec race. Does that make sense? What do we need to call it? Anyways, so Lone Star class, that's going to be, what do we decide on? Lone Star's still in here. Is that a 5-minute heat? Yeah. So, adjust your battery, adjust your prop, maybe build a separate quad, but the idea will be you have to be able to complete 5-minute heat. So I know I've got most of my racing quads because I'm not JT or Bull or anything like that. Most of my race quads will do 4.5 minutes.
Motors on 4s would do it.
Yeah, right? Drop down a cell, or I guess in that case, drop down 2 cells.
Matt Fender, I bet a 5's 1300 would do it as well.
Yeah, I think it'd be fun watching maybe a little throttle management and a more efficient setup versus like your hot balls out setup. That bad? Ooh, ow. Okay, so anyway, same thing with these wires. These wires came pre-tinned. I am just putting a little bit more solder on these wires because that solder that's on there is fight.
Ben B6 super light by blade.
Yep. Yeah, 2-blade prop. I know I can do 4.5 minutes on this 4-inch. Not this one's my backup that I never finished, but on my On my 4-inch, I know I do 4.5 minutes when I'm like practicing. Um, 5 minutes would be, I know it would be like falling out of the sky. So I would have to change prop or put a slightly bigger battery on it. In which case, it's gonna slow me. Either way, it's gonna slow me down a little bit. Okay, so now I'm gonna attach my wire here. Redid the pad, put an extra little blob on my wire. Now I'm just gonna kind of clean my tip and then get a little ball of solder on my tip, and then bring these two together. I think there's still too much that crappy solder on there, on that pre-tinned wire. So I'm gonna feed in some more solder, get a nice ball that covers this thing. Okay. Wire that this thing came with is not the greatest, but I'll show you anyways. So there we are. Got a ball of solder, and it is attached down onto that pad, and it rolled off to the side a little bit on me. Not the prettiest thing, but still attached.
William Hoth could be 10 minutes.
10 minutes? You hear that? Everyone said, 5 minutes is easy, no problem. You guys just bought yourself an extra 5 minutes. There. Who's texting me?
Matt
Marky?
Fender, you could do 10 with a self pit
Scruggs.
stop.
Okay. And with the pit stop. What were we talking about at the last safety meeting there? We were talking about pit stops. Oh, we were talking about optional pit stops. Right? We were talking about optional pit stops. So you could either build a quad to do the 10 minutes or like use your
William Hoth, oh, someone's catching on.
Yeah, use your regular racing quad that only does 2 minutes, but throw in 2 pit stops in there. Maybe that's how you're more comfortable. You think you can get your pit stop in 30 seconds or a minute, and so you got 2 different strategies, 2 competing strategies, right? I like it. This is a great group. We come up with the best ideas, don't we? We just have the best ideas. Screws here. So for going into TPU, I usually just go into PLA with the regular M3. They hold pretty good in the TPU. I have somewhere around here, I have my favorite tap. Like when I model my 3D printed hole, I'll model it as the minimum diameter of a tapped hole, and then actually tap it, and they come out perfect. No need to account for anything weird. My tap is behind me. I think it might be hiding here. Ah, yes. So, always learn new things, right? Rather than those hardware store taps that you get, there are better things out there. So this, crap, I think I forgot the name of this, but the camera here. So anyways, the design of these taps, which like looks like it has a little drill bit tip on it. It's not for drilling though. But this tap pushes the chips forwards in the hole. Right? So it's only good for a through hole, but it pushes the chips forwards, so you can just run this through the hole. And the chips don't get all clogged up in there. In fact, it's cool because when you like when you're tapping your part, a little spiral comes out the other side of the hole before the tap actually comes out. It's cool. Big fan. Little M3. Normally, you get the hardware store tap and you thread it in and then back it off, thread it in, back it off in order to break the chip and all that nonsense. These little guys, you can just go straight in, out. I just wanted to show you that. I don't actually need it. I was going to show you a different screw. CPU. So for TPU, I figure these are good. Get in their view here. That guy. So it's got a nice coarse thread on it, and their little like Torx head screws, and they are awesome for plastic. Yeah, these are little stainless guys, right from McMaster. I'm thinking that this might hold the camera mount really good. Find the hole for it. Yeah. Let's see. I'll get 4 of these. Hopefully, I have the right driver in my case. Yep. What is that? Not labeled. I don't know. It's like a T5 or something like that. Or mount. These are long enough. Oh yeah. Holes are a little clogged up though. Poke them out with screwdriver. So they're clogged up from the very first build layer on the 3D printer, right? So it kind of has a little bit of a brim going on. Not an intentional brim. It's just from the TPU kind of spreading out on that first layer. So I can't see the holes from this side. Just poking my screwdriver in there to get through that first layer. 716 camera mount here. These, I'm wondering if these need to actually have a counter bore on them because of the where the battery is going to be located. Actually, we just ran a countersink deep enough to hide that head would be good. Oh yeah, these screws grab onto the TPU really good. These will do the trick. I don't like having multiple different tools required. You know, it's best, in my opinion, to design your quad for a single tool, right? So one Allen wrench, right? Like a 2mm or a 3mm, and every screw on it is the same thing. So you only need one tool. That's a smart way of going about it. You know, not always possible, but I like to at least strive for that. And let's transfer our motors off of my backup quad, because I never actually needed it because I never broke the primary one. So I think we can seal these motors and transfer them over. These are the DYS motors that have been working good for me. 1407s. Haven't broken any or burned any. What are they? Yeah. SE 1407s, 3600 kV. So not 4000 kV. Most people probably would opt for 4000. I have generally gone on the lower end of the kV. All my quads were usually spec'd with the lower winding in the series. So like I've got most of my stuff has F40s, F60s. For my 3-inch, it's the red bottoms, and for my 4-inch, it's these. Like I said, always gone with the lower
Ben
kV.
B exact same motors on Havlocks.
Cool. They were working good for me. 3-cell, 4-cell. I think I was using. I was comfortable with like a 3-cell 650, and that would get me 4 minutes, 4.5, depending on how you're flying. But it was enough capacity to not have too much. Oh, I'm on my. Why didn't somebody tell me I'm on the microscope? Dan. Oh yeah, so the 3-cell 650. So the 650 has enough capacity to not sag too bad without having to go up to like 800. And since I don't race anymore, I generally go with the lower cell count in order to be in order to keep the quad under control. I just don't have the practice to keep the hotter quad under control. So
Ben B my 4-inch is on 1407 3800 kV 850 mAh4s.
that probably rips, Ben, right? That sounds like a pretty hot combination. Doesn't weigh too much, right? 4-cell 840. Well, 4-cell 850 could weigh a little bit. These screws seem a little bit short to me. I don't feel like I'm getting very many turns on them.
Ben B a little warm.
What does chat say? That is that enough? It just feels like there's not much. What is there? I see 3, right? I see 3 turns. Is there a heavy chamfer in the bottom of these things? Yeah, kinda. Maybe that's why it doesn't feel like I'm getting many turns out of that screw. Well, at least I know I'm going to be safe not hitting the windings. Motor wires pointed right down the arms. Do I want them pointed right down the arms or no?
Frame. I use 6mm screws. Quest_FPV what is happening?
What's going on, Quest?
Matt Fender, it's probably okay, just Loctite it.
Yeah. I don't have any Loctite right next to me. That'll all be solved when I move out. Shop. And for the live stream, it won't be just my desk. The live stream will be the whole shop and all my tools. Proper setup. So I'll just put these in for now, and I will definitely remember to go back and Loctite these. Let's just put 2 screws in each one. It'll be fine. Quest, we're building the King of Hearts. And earlier I was, you weren't in here for the CNC machining, were you? I had the video up of running aluminum on the router. How much fun that is, and how deaf I am now doing that. I have my earplugs with me. A little bit of chatter, but it's gonna work. I can make those enclosures on the router if I want to. Gotta go keep my surface speed up and take small bites. It seems to be working. So anyways, yeah, we're kind of laying out King of Hearts. We've got the Hobby Wing going in. Hobby Wing Nano Stack. We got our ESC down, and we got to get creative with the way these wires are coming in. So Fender, you're saying come into the stack like that, right? Come in between the standoffs and hit the pads. I think that would be easier than what I was thinking. Yep, that'd be easier than what I was thinking. I was thinking something really dumb.
Matt Fender yet.
Glad that we're in the chat together here. I'm not going to tell you what I was thinking. That soldering iron back on. On there.
Quest_FPV, let's see those solder skills.
Oh, I got mad skills, buddy. Soldering iron. Where's Marty? Right, Marty? Fall asleep on me, Marty? Marty has the mad skills. Soldering. I just copy what he does. Right? That's what you do to get
Matt
learn
Fender,
all this
it's a
crap.
little harder
just
to change a motor
when
like
other
that,
people
but it
that know
looks
what
better.
they're doing are working. Harder to change a motor, but it looks better. Yep. And it's gonna be how we have to do it on this guy because battery strap. And this will work out. This will work out good. Everything will be completely out of the way of that battery strap. So, Quest wants to comment about the old skills. Let's see. Nope. How's that, Quest? Is that a decent solder? Decent job on that one?
Cram Nitram 1.
Marty. What do you mean? That emoji looks like I don't know.
Quest_FPV thumbs up.
I
Matt
don't
Fender,
know,
I'd probably
Marty.
change one of mine to look like that since I'm going to put race wires on it anyway, then I won't have to desolder off the ESC if I change a motor.
Oh, yeah. Is that what those are for? I guess that's one of the bonuses for those, isn't it? Marty, you gotta look up the race wires. It's like a printed circuit board for your arm, right? So you run that little printed. It's not like a printed circuit board, right? It's like a flex circuit, but you run that on your arm. I didn't even think about that. It lets you change the motors easy. Oh man, that was a good one. That's a good product. Whoever came up with that one was a good one.
Quest_FPV stop everything. Matt Fender, it's a PCB with 3 traces on it.
Yeah.
Matt Fender white noise.
The
Cram
eye
the
roll
tram one, that's
emoji.
the eye roll emoji.
Oh, okay. Motor wires down here. Uh-oh. The wire go on this one.
Matt Fender, I'm using it since I'm putting 6 arms on and I don't want to splice together wires.
6-inch arms. There's another good feature of those things. Man. That was a good product. Retin my wire. And ooh, this one's a little shorter. Something happened to that one. I'm gonna pre-tin these too because the whatever they use to tin these with is not flowing real great. So Matt, you learned something new just now? I'm
Cram
looking
the tram
forward.
one, I found the race wires.
Found the race wires, Marty? Marty, why didn't you come up with that one? That one was a really good one. Come on, you're the electronic guy. It should have been obvious. That's all I'm saying. I'm looking forward to Saturday, guys. Quest, you ready? Fly. Let's pretend these. Quad set up. A little high speed cinematography. We have some good people down at Riverworks on Saturday morning. Okay. Alright, who's being the idiot and
Quest
timing it?
_FPV. I won't be able to head downtown, but I'll be here for the house stuff.
Ah, alright. Who am I gonna have make very precise low speed maneuvers in front of the camera? That's gonna be JT. Hope he's ready. Hope he's ready to not crash into that camera. Fits. We can get this thing over the top of it.
Nitram 1. What would be awesome if you could make the connection to the motor through the screws?
Marty, that's the dumbest thing I've ever heard. I'm just kidding, Marty. I'm just kidding. Marty and I go way back. I think we have an understanding. Maybe we don't. A little
Quest
tight.
_FPV. We might be able to shoot outside here if you don't mind the dirt backdrop. Matt
Well,
Fender,
I
there
wanted
was a
to get
motor a few years ago that had an ESC in the base.
with an ESC in the base. The spreading wings stuff that all had the ESCs on the bottom of the motor. They were separate though, not like built. Fender, you're saying that the ESC was like what, like right in the skirt of that thing, under the bell housing?
Matt Fender, apparently it wasn't very good, otherwise it would have gotten more popular.
Yeah. Right. So I'm gonna have to put a Spectrum receiver in this guy so that we can test fly it. At least so I could test fly it and film it. But that's looking
Nitram
pretty
1.
good
That's a
so
lot of heat
far.
all in one place.
Yeah. Yep. Right. Make it
Matt
even harder
Fender,
to
yet
get rid
it
of
was
the
a
heat.
round one that fit between the base and the bottom of the stator.
Yeah. Unless you just have like really good cooling built into the design of that motor, but then you're kind of actively cooling it, and you're wasting power doing the cooling, right? Versus just the kind of airflow you get for free just from flying through the air. With me on that one, chat? Okay, what am I gonna need? So I'm gonna need some more parts. I need my XT60s, camera, and my
Matt Fender,
receiver.
if heat was really much of an issue, since that was still 12 amp ESC days on 2204 2300 kV.
Yeah. We need a capacitor on this.
William Hoth, Black Widows.
Not sure where to stick the capacitor here.
Nitram 1. It probably limits the size the S.
Uh-oh. Danger. Oh.
Matt Fender, solder wire off the cap legs, then run it under an arm and tape it there.
Under an arm? Wondering if, I don't know, is this thing small? Even worthwhile putting something that small on there? Maybe I should be stupid and put the huge one. This thing's bigger than the whole. Look at that. Now, Now we're talking. Find a place for this thing. Old side pipe. That thing's so tall, props are gonna hit it. Back. All my quads have a little tailpipe like this.
Cram Nitram 1 asterisk FETs.
Size of the fets.
Matt Fender, I put a 470 on my 3. No
70?
idea if it was needed.
This is a 470. This is a 1000. It doesn't really fit in here very well. I may omit that. I may omit the giant cap on this one. We'll see if we need it. We'll see if we need it when we go fly it and the video sucks. I don't think that this is going to be drawing the kind of current that we need that. I think that's a good stopping point for tonight.
Matt Fender, I don't think you need a 1000.
No, you definitely don't need 1000. Whoa, shots fired at race flight. Okay. Little Predator Micro up front, XT60, video transmitter, receiver. We'll save that for next week. And wrap up on that. My soldering iron off. Yep. Okay. Anything else going on? Buffalo multi-rotor that I should be aware of? Busy. Stuck in my own world, trying to get ready for the bando. Bando. Speaking of bando.
Tram 1, watch the voltage rating on the caps.
Yeah, the voltage rating on this cap's 25, which if you were to 6-cell that thing, that would not work. And this guy's 50 volts. That's probably why it's so big. Not only is it 1000, but it's also 50 volts, right? So it's a little bit bigger. So, okay, what do we got this weekend? Okay, so Saturday, we have a video shoot, a commercial for the Bando race. We're shooting down at Riverworks Saturday morning. And, oh, yes,
Matt
just like
Fender,
clockwork.
You don't need a 50 for SIXS 35 is fine.
35? Yeah. But this 25, this cap's a 25. That's a little bit too low. My buddy's telling me it's time to come to see these, right? Yes. Here. Shoot. No? Okay. So anyways, yeah, so Saturday we're shooting our Bando commercial. Anybody that wants to be an extra on set, I'd like to make it look like we've got a whole party going on down there. Our star of the show is JT. He's driving in Saturday morning to be the star of our commercial. And I don't know, I could use a few extras on hand to hang out with JT, make it look like he's having a good time down at Riverworks. And yeah, so that's Saturday. Sunday, no racing on Sunday. I am not available on Sunday, so I have moved the indoor championship race number 8 to next Saturday, which is Maker Fair. And Maker Fair is going to be at Park School of Buffalo in Snyder, and that's from 10 a.m. to 6 o'clock. And I'm going to split that day in half, and basically in the morning will be race 8 for the spring series, our final race. And then we'll do our little mini award ceremony where we kind of give out our big huge stack of batteries from Ready Made RC and from China Hobby Line. All right, so we've got like
William Hoff, 9 a.m.
I think we've got 8 yeah, we've got 4-cell 1300s from Ready Made RC, and then we've got some 2-cells from China Hobby Line for our brushless and yeah, so then after that, break for a little bit food, and then we'll dive into the outdoor quads. I'm going to set up the regional qualifier track, and I have not submitted the regional qualifier officially, just because we haven't had many races under the new Buffalo
Quest
multi-rotor
_
chapter.
FPV. I'll take the 2 cells if Ben doesn't want them.
But hopefully we'll have an official multi-GP qualifier by
Map Fender, is there power there?
next week. There is power inside the gym, but not on the field. I'll have 2 generators. All right, so I'll have my stuff powered, and there'll be power available on like 2 lines for charging. I don't have a lot of tables, so if you've got tables and tents, you can bring that. Like I said, I've got 40 foot of tent, and I'm under 10 of it, so there's about 30 feet of additional tent available. Just no tables, so if you got folding tables and stuff, bring those down. Keep your fingers crossed for good weather. It's still spring, so you never know what you're gonna get. It might even be snowing, who knows? But weather's looking okay for Saturday morning on Riverworks. 9 a.m. Yep, 9 a.m. at Riverworks for our little video shoot adventure. And then next Saturday, 10 a.m., we start race 8 of the spring series. And then our Buffalo multi-rotor
Matt Fender, last weekend we ran in rain all day.
Last weekend up in Canada. I'm glad to see that everyone's racing, and then that's not holding people back. It makes me also feel better about like the bigger race. Like what if it rains at one of the big races? And to me, it seems like a lot of people that are serious about racing are prepared to race in the rain. As long as I do my job and keep the pilots dry, I think you guys can do your job and get out there and get those quads wet. So, all right, that's I guess that's where I'll wrap it up. Again, thanks to Ready Made, our major sponsor of the Bando. They're also sponsoring the our spring series. They gave us that big stack of batteries to give away, and so yeah.
I don't think anyone had an issue at all.
You want?
People taped their stuff up, but I didn't go crazy with it.
Taped up? Are you using the conformal coating and stuff, or just running it as it is? I mean, I've got some of my stuff wet. I've never done anything, and nothing's happened. But I do see who did the video. Somebody did a video where they were running around. Was it Ladrib? Running around in the rain, and then see it eventually, right? No, it was the snow, right? It was in snow, and yeah, eventually it did. It just locked
Fender,
up.
yeah, but I don't do my ports at all.
Do the ports. So conformal coating on the boards, but you don't go crazy and shoving it in all the ports and stuff like that. Okay. So yeah. Yeah, I'll wrap up. Support Ready Made. There's my RM.
Fender, I just coat the board lightly. Ben B, no coating for me, just one layer of tape.
There we go. RMRC Bando 2018. That's a little discount code if you're shopping on Ready Made's website. All right, they gave that to us just for the live stream. RMRC Bando 2018. So help them, help me put on good races for you guys. And that'll be it for me. I'll see you guys this weekend. All right. Have a good night, everyone.
Matt Fender, I tempted on HDOs if I can find a buyer for my current goggles.
Oh, Matt Fender tempted on HDOs. I was going to leave, but now we're talking about HDOs. Go on, Fender. Is it the clarity or is it the field of view? I
Matt
know I'd like
Fender's
to
Scully
take
had
a
a set up there.
biddy so you got to see them. I know like Mark always had those
Matt
the
Fender had it really
cinemizers
clear.
really clear. Yeah, the cinemizers. That was the nice thing about those is that they have OLEDs in them, and I think like somebody from Fat Shark was saying, well, why don't you use even bigger screens? And it's like they're expensive, right? Those cinemizers were $700 when they were out.
Matt Fender's ices were great, but it was a small FOV.
Yeah, yep. So I think Fat Shark did all right by pulling in an OLED screen, for $500, right? Because they were like $700. It's crazy, but picture was awesome. Man, picture was legit. So I guess if that's like what the Fat Sharks look like, that would be killer. I'm on my HD2s because I love my gigantic
called
screens.
my contact at Zeiss to see if could get them lower a few years ago.
Yeah, they got super hard to find for a little while because the price went down, but they disappeared like right away. Then the price kind of went back up because they were nowhere to be found. No. The downside was all the ground station stuff, all the wires and all the like separate little battery box that the thing comes with in order to charge it. It was like too much wires. They were designed to be kind of sitting in a office or living room or whatever. They weren't designed to be out in the field like the Fat Sharks. Like Mark was running the cinemizers, and the cinemizers look better. But then once he tried the Fat Sharks a couple times, and it's like, oh, I don't have to drag all that stuff out with me. And then
Matt Fender,
so then he
plus
switched
you
over
had
to
to
the
hack them
Fat
into
Sharks.
ski goggles.
Yeah, that made him a little bit better. I was being pressured and lobbied to try to get those cinemizers and ski goggles, but I was able to avoid that project. Got enough projects. Already got 24 projects going right now. So, anyways, okay, that's it. I gotta catch up on my sleep so I can start more projects in the morning. All right, I'll catch you guys later. I'm out this time. See ya.